So I wasn't sure about how this presentation was going to be presented. I thought it was going to be more of a breakout session. So this is an old slide deck that I had for training for EAs. So it's got a lot of the fundamental information in it, but I would prefer if anybody has any question or interjection, just stop me, and I'm glad to have a chat with you guys about it because I want to make sure you get out of it what you want and not just me blabbing on about this stuff, because it can get a little dry. So for energy modeling, I am a registered energy advisor through Natural Resources Canada. It's a licensed position. We have to take a federal test, and we work under the EnerGuide rating system. So the EnerGuide rating system is a good tool. It is not an entirely accurate tool, but it lays down the groundwork to compare homes that currently don't have an ability to compare, right? And in the line of work, I like the adage, you can't manage what you don't measure. So we measure what we can, and we show comparison. It's like I'm trying to lose weight, but I don't know how much I weigh. So you got to try to keep track of that stuff. And it also, a big portion of my job is to educate homeowners on what they currently have, how it works, we can make it better. And part of that is what I like, advising them on, their choices on materials and stuff, sometimes without being biased to a specific brand. So other portions of what you can do with energy advising, other than the EnerGuide, which is what was based on for most of the programs in the past that come and go. There's eStar. R2000 was kind of the baseline for what is now net zero. And these are just benchmarks for performance measurement to reach a certain goal. I call it house math. I just go into your house and I take all the measurements, I break that down into data, and I crunch it, and then I put out a report that hopefully you can ingest, and we make comparisons and recommendations. So it all comes down to the R values, the thermal performance, and the big part is, for me, is the air test. It's the one thing you can't really know until you check it. Like, you can't assume it, you can't guess it. It's the current condition of the house, how it was built, and how it's been maintained. For anybody who doesn't know what a gigajoule is, that's what the rating is in the system, is a gigajoule, and it's I think it's like 2 barbecue tanks of propane, 39 liters of propane. I'm going to try to cut through some of these things just so you don't get lost in the details. And we're trying to keep it to 40 minutes. So net positive energy house, it's just you produce as much energy as you consume, which is cool unless you fill it full of foam. And then your operational carbon is still really low, but you'll never make that back in the performance of the years of the house of what you put in to make it. So that's another conversation I have continually with some of my peers in the industry. And as other people have alluded to, not all EAs are made the same. So the unfortunate part is with these programs, a lot of what I feel are guys just punching the ticket so people can get their paycheck, which it's a general approach for the general public. It's great, you're making improvements, you're making heat pumps, but if you really want to get into the nitty-gritty stuff of it, you got to take a lot more into account. So in the EnerGuide labeling process, we evaluate a house based on the house, not on the occupant. So occupant loads are assumed. That way, no matter who owns the house, we can still figure out kind of what the general consumption of that house is going to be. And part of that is because you don't know how the last person operated that house. They may walk around the house in shorts all year round, right? Or they might wear their winter jacket. So to take that variance out of it, we just evaluate the home based on an assumed load. And so home inspection is essentially structural well-being of the home. Energy evaluation is the performance of the home. This is the current EnerGuide label. So this is what you would get when you get a EnerGuide evaluation. This is what I encourage homeowners to then stick onto their electrical panel. This is the same kind of thing you would get when you buy an energy efficient appliance, like a fridge, dishwasher, all that sort of stuff. So it breaks it down for you. And this is a good portion of what I get into with the homeowner, is where their energy is going. Because some folks think, well, I'm just going to top up my attic insulation, and it's only R30. I'm going to top that up. It's like, well, hold on, let's take a look at maybe your basement. Maybe put something in there instead of nothing. And it used to be a scale based on 100, which was kind of arbitrary, and now it's actually based on a consumption value rather than people trying to figure out, okay, well, what did I score compared to my neighbor? It didn't relate. So they kind of made it a little simpler once you understand what gigajoule is. So you get a homeowner information sheet. It's a more detailed version of the label. Through the process of evaluating a home, we also check the exhaust devices, and that's essentially to make sure that you can't create a negative pressure in your house to have a backdraft on any combustion appliance so that you don't have potential carbon monoxide poisoning. Also, when we check it, so a big portion, like what I was saying, the air tightness test is, if I can advocate for anything for a building, figure out that, because if you don't have proper air in there, and people used to open their windows to exchange the air in their house, and I've been in something like 400 houses, and very few people know how to operate their house, even their mechanical systems, windows, anything. So a lot of what this is going to, like even HRV systems, are like the new ones are self-balancing, because people don't maintain them, they don't check them. So the more you can take away from the homeowner, the more you can be assured it's going to work. So generally, for me, anything over 4 pascals or under 4 air changes per hour, I recommend a ventilation system, just for indoor air quality. This is basically part 9, is what the EnerGuide is specifically designed to evaluate. So if you want to go into industrial complex or something bigger, something with non-residential in it, you got to basically get an engineer to do that. The breakdown, so part 9 under 3 stories, and some people get confused on what 3 stories is. So a little diagram of how you can kind of have 4 stories, but it's only 3. You got to be able to live in the house to have it evaluated. It can't be mid-construction. It can't have big giant holes in it. You can have 1 rock through a window, but not 2. Okay. So multi-use, if there happens to be like a salon downstairs or something, someone's got a home business, we need to evaluate whether there's an issue of depressurizing that residential space for potential contamination. Hopefully not, because you got chemicals down there, but people do all sorts of stuff in their own home. So the building, I don't consider interior wall area. Something like air changes per hour in more advanced evaluations will even remove the interior wall area, because it's not technically part of the airspace. But for this purpose, it's basically the exterior drywall. That's what I'm taking in volume. And then to get a more accurate, instead of just this house is 100 gigajoules, this house is 40, we can also figure out, well, that's because the other house is, 300 feet bigger for intensity. And then we break it down to greenhouse gas emissions as well. Part of my hope for this sort of thing is, because as an energy advisor, I'm already in a house taking all the measurements for existing homes, is I can then translate all that information I've already collected, and I can do a more accurate design heat load and heat loss for any kind of mechanical ventilation that may be remodeled, as well as throw this into the beam calculator, and I can tell you what your greenhouse gas emissions are for your house in the current state, and then also for future renovations, you can add that consideration in. Just more house math. Yeah, very good. So EnerGuide rating doesn't go to 0. It only, or doesn't go below 0. We just stop it at 0. So these are the things we take into consideration for your annual consumption. Renewable contribution will get you down to 0, and then that's where we stop. We don't, that's just part of the technicality, the bureaucracy of the Energuide label. Which, sure. Electrical base loads are the assumptions for like appliances, fridge, dishwasher, all that sort of stuff. Yeah, yeah. You can fiddle with it in the program, but again, for this purpose for Energuide, it's just, yeah. Again, Hot 2000 is the program that I use for this. It's the government produced computer program from the 80s that they feel still works. They're looking to update it. I think they want to go online with it. There's also a lot of talk about virtual evaluations, but that's a whole nother thing. Heated floor area. Just, I thought it might be interesting for folks. So technically the heated floor area is the actual floor. It's if you have an upper level open area, that doesn't count. It's just volume. They consider a crawl space to be 3.94 feet, which is, I thought was interesting because I'm pretty sure the code is different than that for a crawl space. Yeah, and then they also changed it for another portion of it. I think to meet the code is like 5.2 feet now. But technically, when I model it, the crawl space is. There's a lot of strange, redundant, bureaucratic things in this because it's a government program. But you kind of get to learn. The concept is there. It's essentially surface area, different concepts of the home that you're calculating, and yeah. So there's different levels of service. Basic service is just me coming to evaluate the house, and then there's the upgrade service where I make recommendations. So the blower door test is 8 data points between these two pressures and taking integers of 5. And in the end, after calculating volume, we can calculate how much air turns over in that in 1 hour based on a 50 Pascal pressure. So that's what ACH is for our metrics for this. So 5 air changes per hour means if there's a 50 Pascal pressure in the house, which is roughly 32 km/h wind on all sides of your house. So it's an exacerbated situation, but it allows us to have a consistent measurement. So 5 air changes per hour means the volume of that house will change over 5 times in that hour. So the national average is 3.57. I don't know how they got there because I see a lot of houses worse than that. New homes, they want around 2.5. Net zero is 1.5. Passive house is 1.6. 0.6, which is really tight. And you really need air in there.
Do you like breathing?
Yeah.
Have
you tested brand new builds to see if
Mhm.
they're meeting the average?
I have, yep. Yeah, so conventional homes, yeah, not a lot of them meet 2.5. Because it's all in the details. If you don't know the details, if you assume you're building an airtight home, you don't know. And I would love to believe you that you are, but you can't tell me you are and not test it. So, like I can say I'm a good swimmer, but then I never go in the water. So, yeah, I would love to see builders do air tests. And then once you establish the fact that you have met that, you can kind of assume that your practices can carry you forward, and we don't have to be as stringent during the test. We can just come in for a final and give you the number. But it hasn't been adopted yet. It's not accepted because it's one more thing that builders have to deal with, and they don't really want to. And there's no stipulation in the code that says you have to have an air test. It says the builder has to, within reason, provide an airtight home. But there's no metric for that. So.
And I can tell you that the home builders on the code committee,
Yeah.
they fight this tooth and nail.
Yeah.
They're happy to have it as an option for higher tiers.
Yeah.
They're very happy about that.
Right.
But they do not want. They want to always be able to build at their minimum.
Yeah.
But the minimum will never include it.
Right.
And there's a whole
Which
bunch
is
of people
weird.
on the code committee
Yeah.
who want it included.
Mhm.
But anyway, yeah. These are the fun conversations.
Yeah.
Yeah.
Okay.
Yeah.
Some of the renewables that we include in this modeling process. Hot 2000 does provide a heating and cooling load. The cooling load is right off. And the heating load is in the ballpark. It's the same sport.
Yeah.
If you want to design a heating system for the building, you got to do an F280. This will tell you a ballpark, and you can confirm your numbers kind of if you're in the right area. But yeah, I've done F280s on houses as well as the Hot 2000, and there's issues. And even Energuide has said, stop using this as a reference point. Like, it's just there for reference. So,
And F280,
oh, sorry, that's the standard for
CSA, it's a CSA.
it's a CSA standard, yeah, for
And it's
calculating a design for
It's baked into 9.32.
Yeah.
It's in the code, and that was another, that some people wanted it out, and we took a look and go, and it's like, no, you don't want that out.
yeah.
But anyway, yeah.
Yeah, we have to take timestamp photos of everything. So when the client calls me up and says, I already did it, can you come and do the initial evaluation and just kind of fudge the photos? No. Yeah, I just take photos of everything. We collect as much as we can without personal data. I'm just interested in the building. I don't really care about what you do in your house. Like, so many people have little grow ops in the basement. Yeah, like, I don't care. Yeah, I just assume how much power you use. I'm not measuring. So these are the house types that we can use. We can do multi-unit residential buildings. It is an additional requirement to take for testing. And yeah, really all it is it's more complex for the air tightness testing, really, and some of the operational things. Atypical loads that we don't use anymore, but we can note. I threw this in for interest, so we have a standardization from Natural Resources Canada of material resistances, and so don't believe what the spray foam guy tells you. That's what we measured at 5.2 per inch. Okay, it's like 4 inches is not R30.
Yeah.
And that's it. So I would love to answer any questions you guys have about energy evaluation, the exciting world of energy modeling. Yeah.
How do you find a good energy evaluator?
Yeah, good question. So I am a member of the Canadian Association of Consulting Energy Advisors. It is a professional association that I pay to be a member of. We are essentially dedicated to the betterment of the industry and a stable industry. And so there's a listing of us on that site. So it's an additional accreditation. We have to do educational credits. And then there's additional training that we can do. So in addition to this, I also have equipment to do duct testing, flow testing for mechanical systems. So if somebody was to be removing an old system, I can check the flow of the ducts so that if it happens to be like on the cusp of whether to do a 1.5 or a 2-ton unit, we can help them determine what size they want to do. So stuff like that, rather than just because the way that they implemented the search and find for the grant was ridiculous. You'd have to find a big corporation, and then they'd have to send it down to the EA, and that EA might not be the same person that did the first. Anyway, there's a whole lot of stuff I could talk about how difficult it's been through the grant process, but it's like finding any contractor. Get referrals, ask for recommendations, look at their past work, see what their accreditations are. I would love for people to have a conversation with them before they show up to the house. That was a big thing for me. So I've been operating my own business for a year now, and a big thing for me was that connection to customers. They're calling me. I'm the person that's coming to their house. Like if you call a plumber, that plumber's coming to your house. That's the guy you talk generally, unless it's a larger corporation. But to me, it's that relationship between the homeowner and me. and providing that information for them, relaying that information so that I'm there to communicate with them what I saw on site rather than having to go through the, press 2 to get so-and-so and then, yeah. So to get a good EA, go to Casey. Yeah.
I'm curious to hear about the particularities of a single unit within a multi-unit building.
Okay.
How is it different? And how do people use the data differently in whatever interventions they might make?
So for the biggest benefit, we'd like to model the whole building. Because we can do single units, but the numbers are going to be very slant, because like for a single unit, a multi-unit building, you potentially have one exterior wall as your loss, and then all the other adjacent units affected. So you can do like a guarded blower door test to check, because there's going to be some leakage between them unless it was compartmentalized, which is really only a new thing in multi-unit building. So you're not smelling what everyone else is cooking.
Yeah. What about like in Montreal where everything's side by side by side, but it is masonry?
Oh, like townhouse, row house? Yeah, we have protocols for that. It's a party wall between the two units, so we just test it as an individual unit. And you can do a guarded test there as well if you want to really check. But for the purposes of EnerGuide, we evaluate that as an independent home. And so that unit would be evaluated on its own credentials, yeah. Yeah.
So what setting do you use to talk about those walls they're exterior to that unit, but they may not be an exterior wall?
We assume they're not there.
Oh, okay.
So it's an interior wall.
Okay.
Yeah,
Yeah.
yeah. To evaluate a multi-unit building, but like a row house, how do I address the party walls between the units? And we just assume that they're interior walls. Yeah, yeah, yeah.
I had an interesting conversation with someone who's trying to essentially game the system, and so they're trying to figure out if they could, and I wanted your opinion on this. They said, well, I'm going to do my initial blower door testing in winter, because this way with everything contracting, all my holes will be bigger, so it'll look really bad. And
Yep.
then I will do my second test in the summer when everything's expanding, my holes are less, so my air sealing will be tighter than whatever work I'm needed to do.
Sure.
And I was like, how valid is that? And is
Yep.
there a best time of year to test and worst time of year outside of it being super windy?
Yeah, yeah. So yeah, there is an effect there, the environmental effect of the building. If you're not doing anything to change your air tightness of the building, it's not going to have a significant effect. Yeah, it's not worth your time to schedule it like that. I wouldn't say. It definitely and there's also a variance within day to day. So I could set up the blower door 3 days in a row and have 3 different outcomes because there's a margin of error. But for the purposes of this and getting a grant, there's like a 10% increase in your air tightness that you need to achieve, which you'll never get by scamming it like that. Yeah,
That was my argument, but I was
Yeah,
just like,
yeah.
not.
Yeah. On that note, there was a lot of issues with people doing what we call drive-by blower door tests, where they either would just make up the numbers, or they would do the test with a window open initially, and they would come back, and so this is a big thing with the last Enbridge program. Everybody was meeting their air tightness target. It's like statistically not possible.
Yeah.
So they are cracking down on that. So we do have automated systems now that they want to see generated reports. That's a big part of the timestamp photos. Is I have to take a photo of the unit in place. Yeah, yeah.
Well, it all takes time, right?
Yeah.
So, do you ever want to figure out your hourly rate?
For me,
Yeah.
I know what my hourly rate technically would be. Yeah, doing this.
And you know that you're doing it honestly.
Yes.
Because the guy doing the drive-by, his hourly rate's probably quite a bit higher.
Yes. Yeah. And they're not, to me, they're just not providing the service that people are hiring them for. So, yeah. And a big part of that was like when this grant got announced, the government arbitrarily decided how much an evaluation was worth
Right, yeah.
without consulting energy advisors. So thank you for that. So they had said initially, so part of the benefit of being a Casey member is we advocate for the industry. And so the initial announcement was your energy evaluation would be free. And we're like, no, 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 no. like $600, it's a free evaluation. They're like, no, no, you can't set the cost for us. So people did get $600 towards the cost of their evaluation, but I still can charge whatever I like. So it was initially when I was doing evaluations, so I've been doing this like for 6 years, an initial evaluation was almost double what it is now. So it was a race to the bottom. You saw a lot of companies come out of the woodwork and start providing these services for people. They were pushing people through to get it registered and evaluated, or to registered and licensed. And so I would just urge caution when finding, and like anything, contractors, get quotes. I always recommend people get 3 quotes from a contractor. I wouldn't suggest anything else from an EA too. Call around, see what, oh, now you don't have to because there's no program, but
Yeah.
it would be great. Going forward, we are pushing this as to do a standard with the code, with blower doors, and assist in other trades. With mechanical ventilation systems and things, it is a value-added service that we're trying to get more standard. So hopefully I can illuminate a little bit of the value of the service that EAs provide. And yeah, I think that's all the questions. So thank you for your time.
Thank you, Dave. And